Forensic science can involve absolutely anything in everyday life. The main sorts of things I suppose we spend our time doing are things like body fluids and tissues with DNA associated with them. Obviously fingerprints are really important as well. Textile fibres from clothing and other furnishings, glass and paint and other types of particulates. Mobile phones and other digital media are increasingly important. Any kind of trace, we can get involved in analysing and comparing and then working out what it's likely to mean in the context of the case. One of the most interesting kinds of evidence is textile fibres, because not only do they come in a wide variety of different types and colours and so on, so there can be very good evidence in themselves, but also they can lead you to specific items in cases where you really ought to focus your attention, and that then can lead you on to things like DNA and marks evidence and all kinds of other kinds of evidence. In the Coastal Path case, there was some suggestion that one of the key items we had there, a pair of shorts, hadn't been worn by the suspect, but had been worn by another member of his family. And there we were able to show through body fluids on the shorts that actually there was DNA there that absolutely came from the suspect, but also came from his wife in the sorts of circumstances that you might expect in a marriage, to put it nicely. So we were able to, through that sort of thing, to show who the wearer was and sort of confirm it in an interesting way. Blood pattern analysis is an incredibly powerful form of evidence for telling you what went on somewhere. So it's one of the first things you do at a scene where blood has been shed, is to have a look at the patterns the blood forms. And there are lots of different things you can do. I mean, first of all, using your eyes and thinking about it, that's a very good start. And obviously photographing it so you've got a proper record of it. And with blood patterns, they tell you two main things. They tell you what happened and the sequence of events at a crime scene, but they also absolutely point you to where to go to sample for DNA profiling, to tell you from whom the blood came. But DNA profiling is a quite expensive process, and so obviously you want to keep the number of samples you send for DNA profiling down as much as possible, and you do that by understanding the pattern and then by working out which samples you really do need to know from whom the blood came. There are lots of different sorts of bloodstain patterns that you get at crime scenes, and generally they tend to be combinations of some basic elements. And three basic sorts of elements are, first of all, blood that's just dripped passively from a wound, so you get dripping and spotting and splashing from that, and tends to be the larger spots and splashes. Then you can get blood spatter, where wet blood has been split up by some kind of force. So in an extreme example, it could be split up through gunshot. Slightly less extreme, as if someone had been punching or kicking someone, then you get also this pattern of blood spots that are sort of finer or less fine, depending on the circumstances. And then there are the blood stains that arise through contact between something with wet blood on it. So you get sort of smears and swipes and wipes and those sorts of patterns. But as I say, normally blood patterns are a composite of these different basic elements. And the trick is really to work out, what you've got from these composite patterns. Without doubt, the most significant advance in forensic science in my career has been the development of DNA profiling. Absolutely, without doubt. It's transformed the strength of the link between traces left on clothing, for example, and individual people. The main kinds of samples that you take are the main body fluids, so they would be saliva, semen and blood, but also very much these days also skin flakes, and you get skin flakes off the surface of clothing and off other surfaces obviously. And there are a whole variety of different collection techniques depending on the circumstances, depending on the item and the amount of material you think you might have. Sometimes you can't even see it, and they range from swabbing to cutting bits of material out to removing the surface debris from an item or surface material from an item using sticky tape and then cutting up the sticky tape into tiny bits. And so there's all sorts of ways in which you can collect DNA. It's horses for courses, and you just think of each case and each item as you're doing it, and what's the best way to get the DNA off it. But then you have to be incredibly careful that there couldn't be some innocent explanation for it. So you have to understand the context of for example, the crime scene and the suspect's relationship with the crime scene, if they'd ever been there before or they'd handled something that's found there. You have to be really, really careful in interpreting the findings from minute trace material. So that's where the difficulty comes, and potential accidental contamination of items that you're looking at and that you get results from.